Welcome to A-lvl Classroom. In this video we are working from the C1 Core Maths textbook by Pearson. In this case we are working with Chapter 1, Exercise 1B, questions 7 to 12. And as per the previous video, we are working with the rules of indices and we are simplifying the expressions that are given to us. So in this case we head straight to question number 7. 10x to the power 5 divide by 2x to the power minus 3. So if we were to rewrite this, we would have our coefficients first. So it would be 10 divide by 2. Then we would have our bases, the x, and we would apply rule number 2 to them. So multiply by x 5 minus 3. This will give us 10 divided by 2 is 5. X 5 minus 3 is 5 plus 3, resulting in 8. And that is your final answer. Question number 8, you can see this is a combination of indices rule number 3 and indices rule number 2. So we will start by solving the first term here. So we start p to the power 3 multiplied by 2. So we will have p3 multiplied by 2, and that is according to rule number 3. Divide by p to the power 4. So here we have p to the power 6 divide by p to the power 4, and that is p6 minus 4, resulting in p squared. Question number 9. It is the same process, but please, in this case, a mistake that is made very often by students is that they follow question or rule of indices number 3 very well for the indices of the base, in this case the a, but they often forget that this indices on the outside of the bracket applies to the 3 or the cube of the base a, but it also applies to the base of 2. So in this case we will have 2 squared a6 because it's 3 times 2 divide by 2a to the power 3. So we effectively have 4a to the power 6 divide by 2a to the power 3. Now 4 divided by 2 gives us 2. A6 divided by a3 is 6 minus 3, resulting in 2a to the power 3. We now move over to question number 10. We have 8p to the power minus 4 divide by 4p to the power 3. So we start very simple. 8 divided by 4 will give us a 2. Then it is to the bases of p. So it will be p minus 4 minus, and then your 3 from the second one. So this will result in 2p minus 4 minus 3 gives us minus 7. And as I showed in the previous video, when you get an answer like this, it is 100% correct unless the question states that you have to give all indices as positive indices, in which case you will have to apply rule number 4 of your indices rules to convert or change this negative indices into a positive one. Your answer in this case will be then 2 divide by p to the power 7. And that is just for interest sake. Question 11. 2a to the power minus 4 multiplied by 3a to the power minus 5. Very simple. 2 times 3, that will give us 6. A to the power minus 4 plus minus 5. These are the indices with the base A. This will give us 6a minus 4 plus minus 5. That is minus 4 minus 5 will give us minus 9. And once again, just if it is stated to give it as a positive indices in your final answer, you will have 6a to the power 9. Question number 12. Here you can see we have multiple bases. We have our coefficient, we have a base and a b base. So how will we solve these? Well, very simple. Coefficients, 21 divide by 7, that will give you 3. That's the easy one. We now go and we only work with the base a. So a, 3, considering that it is a division sign, it will be minus, and there is no indices for the a with the 7ab, so it is a 1. Then we apply the same rule for the base b, where it will be b, 2 minus 4. This results in an answer 3a squared b to the power minus 2. And once again, just if you have to write all your indices as positives, we will have this as follows: 3a squared in the numerator position, and b squared, you can see we changed it to a positive, in the denominator position. In the next video, we will look at question 13 to 18 of exercise 1b.